Hi everyone, so in this video we'll try to solve some exercises about conditional probabilities. Now let's start with the first exercise. In a shooting game, we have two players that compete independently. The probability of the first player hits the target, let's call it event A, PA, is 4 over 5, and the probability that the second player hits his target is 3 over 4, which is P of B, the second event. So now let's calculate the following probabilities. The first, what is the probability that both players hit the target? What does this mean? It means A and B at the same time they hit the target, which is P of A inter B. We want this. Since we have this information that they are independent, that means we apply our formula that says if A and B are independent, the probability of the intersection is simply the product of the probability. So it is probability of A times probability of B, and we get 3 over 4 times 4 over 5. In the end we get 0.6. So this is the answer for this question. Our second question, neither of them hits the target. No one of them. So that means A didn't happen, and at the same time B didn't happen. So how to find this probability? If you remember De Morgan law, we apply it here. So the De Morgan law says that the probability of the intersection of the complement is simply the probability of the complement of the union. So this one becomes this. So it is probability of the complement of A union B. And we know that the complement of the union is 1 minus the union. So get this. And simply the union, we apply our formula that says the union of A and B is PA plus PB minus the intersection. The intersection, we found it here, which is 0.6 or 3 over 5. 3 over 5. So in the end we get 1 here minus PA plus PB minus the intersection, and we get this result, which is the probability that both A and B didn't happen. Now the last question, the probability that only one of them hits the target. Only either A alone or B alone, which is simply P of A delta B. One of them, only one of them. So P delta, we apply our formula. We know that P delta B is PA plus PB minus twice the intersection, and we get 0.35. So this is the result for this question. Now let's solve another exercise number 2. So in the factory there are 3 canning workshop, H1, H2, H3. The production is distributed in the following proportions respectively: 20% in the first workshop, H1, 50% in the second, and 30% in the third. The estimated percentage of defective cans produced in each workshop is 1% for the first workshop, 0.4% for the second, H2, and finally 0.6 for the third, H3. Now based on this information, let's find the following. So first, the first question, the probability that a randomly selected box is from the defective production. Now here. So the probability that randomly selected box is from the defective production means we want to find the probability that this product is defective, P of D. So before finding this, let's write down all the information we have. So the first information we have is the probability that this product is from each workshop. So the probability it came from the first workshop is 20%, which is 0.2, because we know that 20% of the production is or came from H1. Now P of the second H2, the probability that it came from the second workshop is 50%, so it is 0.5. And finally the probability that it is from H3 is 0.3, which is here 30%. The additional information we have is we know that the probability of defective, that the product is defective, if it is from H1 is 1%. So how can we write this? It is actually the probability of D, it is defective, given it came from H1. If we know it is from H1, if we know it is produced in the first workshop, we know that the defective rate is 1%. So it is 0.01. Now the second information, if it is from H2, the probability that it is defective is 0.4%, which is not this but 0.004. We divide this by 100. And finally the probability that it is defective, if we know it came from H3, is 0.6 divided by 100, and we get 0.006. Now let's answer this first question. The probability that a randomly selected box is from the defective production, that means P, it is defective, whatever, it doesn't matter from which workshop it came here. So what I want is the probability that this product is defective. That means it is the probability that it is defective and it came from H1, or it is defective and it came from H2, and it is defective and it came from H3. So here it is the sum actually of the probabilities that it is defective and it came from different workshops. So here we know that the probability of the intersection, we saw this in the last video, is actually the probability of an event given the other times the known event. So PA inter B is actually PA given B times PB. Or we can write it also like this: PB given A times PA times the known event. So let's use just this one. So now let's apply this formula, this one. Let's apply it here. So we start with this: P of D and H1 is simply P of D given H1 times PH1, and this one, P of D and H2, is P of D given H2 times PH2, and the same thing for this. Now how to find the our result? We have everything here. So P of D given H1 P of D given H1 is 0.01 times P H1 is 0.2 plus P of D given H2 0.04 times 0.3 times 0.5, sorry, here, plus the P of D given H, sorry, so H3 is 0.06 here, times PH3, which is 0.3 times 0.3. In the end we get 0.0058. So this is the probability that this product is defective, and it doesn't matter from which workshop it came. And we can in the end write this beautiful formula. You can use it, which is the probability here of D is simply the sum of probability of D given H E, whatever the workshop it is produced in, times the probability of the workshop HE where it is produced. So you can apply directly this formula and you will get the same result. Now let's solve the second question. The second question here says we are looking for the probability that a randomly selected box is from the non-defective production, which means we want the probability of D bar, which is simply 1 minus P of D, and we get 1 minus 0.0058. In the end, this is the result for this question. Now the third question: identify which workshop has the lowest percentage of defective production. Now here the question is percentage. If we use percentage here, we just check which one has the lowest percentage here, which one here has the lowest percentage, and we see that the lowest one is 0.4, which is in the second workshop. But let's use here, instead of percentage, probability, the probability. Now if we want to find the workshop with the lowest probability of defective production, we need actually to find the probability that it came from each workshop given it is defective. So what is the probability it came from workshop 1 if we know it is defective? Here we apply the Bayes theorem. So it is here PH1 given D is simply, we said we reverse here, so it is P of D given H1 times P H1 divided by P of D. Now we have everything here. We have P of D given H1, which is 0.01, times PH1, which is 0.2, divided by P of D that we have calculated here, which is 0.0058. We find the probability for PH1 given D. Now we do the same PH2 given D, the same steps, and we get this. And we also do the same for PH3 given D, we get this. The lowest here, the lowest probability, so if we found that here in this example, we found that the probability of this product being produced in H3 given it is defective is the lowest probability. So H3 here has the lowest probability of defective production. Or you can also compare directly. Actually, you can compare directly what we have here in the numerator, because all of them has in denominator as P of defective, so we can just take this one. or simply this one and compare to this one compared to this one. The lowest means this workshop has the lowest probability of defective production. So there's two exercise for illustrating how probability or the conditional probability works. Thank you for watching, and in the next video we talk about the discrete random variable.